So our topic for today is work, energy, and power. Extremely important in terms of MCQs, in terms of questions that you'll get, whether it's P1, P2, right? And also when you will proceed towards your A level, this chapter is going to be really, really useful, right? Work, energy, and power, right? You should know that, for example, you have an object here. This is an object, and you apply a force F, right? And as a result of this force, this object moves a certain displacement, right? It moves a certain displacement, which we call S. This is the displacement that we have, right? So this displacement is basically what? It is the distance that is moved in the direction of the applied force. Distance moved in the direction of the applied force, right? So you should know this, that the work done by a constant force, which we call F, is given by the product of the force and the distance moved in the direction of the applied force. So the formula here becomes W is equal to F into S. Here W is the work done. Here F is the force. This S is what we call the displacement. Okay, this is the distance moved in the direction of the applied force. This is the work done, force into displacement. Is work a scalar or a vector? Work is a scalar, even though you're multiplying two vectors. But if you take the dot product of two vectors, this is something that you will study at a higher level, right? SI unit for work is joule. And you should know that 1 joule is precisely 1 Newton meter. But you should not confuse Newton meter of moment with joule, right? They are different. If they ask you to define joule, you should know that 1 joule is defined as the work done by a force of 1 Newton, which moves an object through a distance of 1 meter in the direction of the applied force. That is 1 joule, right? If you have an object here like this, and you apply a force of 25 Newton here, and the displacement is 2 meter, what is the work done? That is 50 joules. So the work done here is going to be force into displacement. And you know that the force is 25 Newton and the displacement is 2. So you get what? You get 50 joules here. हमारे पास ये ऑब्जेक्ट है, फॉरवर्ड फोर्स इस पे 50 न्यूटन लग रही है, फ्रिक्शनल फोर्स इस पे 20 न्यूटन लग रही है. द फ्रिक्शन इज and it moves a displacement of 5 meters. The question that can be asked here would be, if this is the forward force, that what is the work done by the forward force? 250. सिर्फ forward force की बात हुई है, right? So the work done here is going to be precisely F into S, and F is 50. And S, which is the displacement, is 5. So this is going to be 250 joules of work done, right? And if they ask you work done against friction, so how will you write it? S 20, S is 5. So it's 100 joules. अब हम इसको use करेंगे work done by the resultant force. What is the work done by the resultant force? G, what is the work done by the resultant force? Yeah, now you can write here the work done by the forward force minus the work done against friction. So you have here 250 minus 100, and this is going to be 150 joules. There are certain conditions when no work is done. The conditions are the work is not done. Number one, when there's a person here, this is a wall. Let's say there's a wall here on an object, and there's this person, right? And this person is applying a force here, but it's not moving, right? This person is applying a force, and this wall is not moving. The displacement is zero. Force is applied on the objects such as this wall, and the object does not move. This is the case number one that we have, right? Case number two is you have an object and there's a person here. The person is moving like this. This is the direction of motion of the object. The force that is being applied by the person is perpendicular to that, right? So when the force and the direction of displacement, they are perpendicular, the work done is zero. Should know that no work is done when the direction of the force and the direction in which it moves are perpendicular to one another. So this is a case when you have, for example, a force here. There's an object. ये 20 न्यूटन की force यहाँ पे लग रही है, और आप you're moving across the room, holding some books, and you're applying a force upwards, and you're moving across the rooms. मतलब आप आगे जाते जा रहे हैं, आपने books को एक जगह पे hold किया हो. The work done on the object is 0 joule, since the force and direction of motion are perpendicular to each other. This is also evident in circular motion. You have a circle here, an object is moving in a circle, and the direction of the force, is towards the center of the circle, right? And let's say there is an object, and this is the direction of motion of the object, right? This is the direction of speed. The speed and force, they are, this is the direction of the velocity here, right? So I'll call this the direction of, so this is the resultant force towards the center of the circle, right? This is the direction of motion that we have. And you see that they are perpendicular to each other, right? So when this happens, again, the work done is zero. So in circular motion, the work done is zero. Remember that work done.
Yeah.
G.
एक सवाल है कि do they हम इस तरह कह सकते हैं कि the direction of motion and the direction of force are not in the same direction.
But if they are not in the same direction, तो उसका कोई ना कोई component आ जाएगा. आप आगे ये A level में भी पढ़ेंगे. लेकिन जब बिल्कुल 90 पे होता है ना, तो वर्क डन जीरो होता है. 90 पे नहीं होना चाहिए. 90 के अलावा कोई और किसी जगह पे होगा ना, अगर इस तरह से भी होगा, तो कुछ ना कुछ वर्क डन हो जाएगा, क्योंकि उसकी कुछ कंट्रीब्यूशन हॉरिजॉन्टल जाएगी, कुछ कंट्रीब्यूशन वर्टिकल जाएगी. तो जो उसकी कंट्रीब्यूशन हॉरिजॉन्टल जाएगी ना, वो वर्क डन करवा देगी. वर्टिकल पे ठीक है, समझ आ रही है? वर्टिकल पे कोई कंट्रीब्यूशन हॉरिजॉन्टल में है ही नहीं. ये आप लोगों को ख्याल रखना है. सो द वर्क डन बाय एन ऑब्जेक्ट इन अ सर्कल 0 joule. The work done by an object in a circle is 0 joule, since the force and the direction of motion are perpendicular to each other. Remember that. Okay? If the force is here towards the center, the direction of motion, which is the velocity, is perpendicular to the force. Let's talk about energy now. You should know that without energy, you can do nothing, right? You cannot do any work. So energy is basically the capacity to do work. Energy is the capacity to do work. They are the same thing, right? They have the same units, and you should know that the SI units for energy or what they are joule, right? There are different forms of energy that we have. We have the chemical energy, right? And the chemical energy is found where? It is found in fuels such as oil, wood, coal, electric cells. ये जो बैटरीज होती हैं, सेल्स होते हैं, उनमें केमिकल एनर्जी होती है, वेरी इंपॉर्टेंट. फूड, explosives. Then we have nuclear energy. न्यूक्लियर एनर्जी होती है किसमें जी? एटॉमिक बॉम्ब्स में, न्यूक्लियर रिएक्टर्स, स्पेशली यूरेनियम जो आपके पास एक मेटल होता है उसके अंदर, ठीक है, फाउंड इन यूरेनियम. इज दैट क्लियर जी एवरीवन? रेडिएंट एनर्जी. Radiant energy is radiation से related है, right? We'll study electromagnetic spectrum in the topic of waves such as visible light, radio waves. We have infrared radiations. We have ultraviolet radiations, X-rays, gamma rays, right? Number 4, we have the electrical energy, right? Where is electrical energy found? Energy associated with current in electric drills, power tools, immersion heaters, and electrical appliances. Okay, kinetic energy के बारे में अगर आप देखें तो all objects in motion, gravitational, potential, के पास raised objects जो होते हैं जैसे waterfall है, waterfall. Number 7, we have elastic potential energy. So we have compressed or stretched springs, bent condition of a diving board, stretched elastic band of a catapult. All of these consist of elastic potential energy, right? It's also the strain energy, elastic potential energy, right? Then we have another thing which we call electrostatic potential energy. It is the potential energy between electric charges. Then finally, we have another energy which is internal energy. This is the energy possessed by the atoms and molecules in the form of microscopic kinetic and potential energies. मैकेनिकल एनर्जी जो होती है ना, इसमें दो किस्म की मेन एनर्जीज आ जाती हैं. नंबर 1 इज काइनेटिक एनर्जी एंड द अदर वन इज द पोटेंशियल एनर्जी. पोटेंशियल एनर्जी में दो और क्लासिफिकेशन आ जाती हैं, ग्रेविटेशनल पोटेंशियल एनर्जी, और एक हमारे पास आती है इलास्टिक पोटेंशियल एनर्जी, राइट? काइनेटिक एनर्जी जहां तक है उसका जो डेफिनेशन है, दैट इज व्हाट इज इट इज द energy possessed by an object by virtue of its motion. Any moving object has kinetic energy. I have here an object. This is a car. Car has a mass in kilogram, right? Let's say the car has the speed v and the speed of the object is in meter per second. So इसकी जो काइनेटिक एनर्जी का फॉर्मूला होगा वो क्या होगा? E with a subscript k. E energy k is for kinetic, that it's going to be half mv square. Square जरूर आएगा v पे. This is the kinetic energy in joules. This is the mass in kilograms. This is the speed. आपको अगर ग्राम में mass है तो आपको किलोग्राम में करना पड़ेगा अगर आंसर जूल में देना. स्पीड अगर किलोमीटर पर आवर में है तो मीटर पर सेकंड में आपको करनी पड़ेगी. This is the speed of the object in meter per second. So let's say if there's a car which moves with an initial velocity u, right, to a final velocity v, then you should know that the change in kinetic energy would be what? Half mv square minus half mu square. अगर इनिशियल वेलोसिटी 0 है तो हाफ mv स्क्वायर आंसर आ जाएगा क्योंकि वो रेस्ट पे थी शुरू में. So let's say if you have a car here, mass is 5 kilograms, speed is 10 meter per second. Kinetic energy is going to be half mv square. The mass is 5, the speed is 10. This is going to be 1/2 into 5 into 100. The answer is 250 joules.